If oxidation and reduction takes place simultaneously, such reactions are called as what? Redox reaction. Electronic conductors are also called as metallic conductors. What are conductors? Conductors are the substances which allow electric current to pass through that. Such substances are called as conductors. The electrochemical cells means the devices which are carrying out indirect redox reaction are called as electrochemical cell. Hello my dear students, I am Renuka Ashok, Department of Chemistry, Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. My dear student, today I am going to deal with second chapter of your PUC board syllabus, that is Electrochemistry. Electrochemistry. Second chapter of your chemistry syllabus, Electrochemistry. In that, I am going to deal with the first session. In this session, I am going to discuss about what exactly electrochemistry, what is electrochemistry, what's the importance of electrochemistry, why you had to study electrochemistry, what is electrochemistry, what's the importance of electrochemistry. For example, if you are going to study about some concept means, so in that concept you have several uses. Similarly, today I am going to deal with electrochemistry means was the application of electrochemistry, and you had to know about three types of reaction: oxidation, reduction, as well as redox reaction, conductors and its type, electrolyte and its type. Today, I am going to deal with the basic concepts which are required to understand electrochemistry chapter. If you want to know about the electrochemistry concepts, you require some basic terminologies. That comes under the first session of electrochemistry. What is electrochemistry? What's the importance of electrochemistry? So in electrochemistry, we are using terminologies like oxidation, reduction, redox reaction, conductors. What are conductors? What are the two types of conductors? And what are electrolytes and what are the two types of electrolytes? Which all comes under in this session. Now, first let us discuss with electrochemistry. What is electrochemistry? Now, electrochemistry is the branch of physical chemistry which deals with production of electricity from the energy which is released during spontaneous chemical reactions. During spontaneous chemical reaction, one energy is released. That energy is known as free energy or Gibbs free energy. Free energy or Gibbs free energy. From that free energy or from Gibbs free energy, we have to produce electricity. We have to produce electricity, and that electricity is used to perform or bring out non-spontaneous chemical reactions, which are used to perform non-spontaneous chemical reaction. So, what, my dear student, what is electrochemistry? Electrochemistry is a branch of physical chemistry which deals with production of electricity from free energy of the spontaneous chemical reaction, and that electricity is used to do a useful non-spontaneous chemical reaction. What is the meaning of spontaneous chemical reaction as well as non-spontaneous chemical reaction? Spontaneous chemical reactions are those which takes place on its own without using any external aid. For example, rusting of iron, movement of gaseous molecule from higher concentration to lower concentration. These all are spontaneous. They takes place on its own without using any external support or external aid. Such reactions are called as what? Spontaneous chemical reaction. Few reactions that takes place only after using external support or external aid. Such reactions are called as what? Non-spontaneous reaction. Therefore, electrochemistry means we have to produce electricity from free energy of the spontaneous chemical reaction and use that electric current to perform or do useful non-spontaneous chemical reaction. That completely comes under the reaction, that completely comes under the branch electrochemistry. Electrochemistry. What's the importance of electrochemistry? Why you want to study electrochemistry? Because Production of metals like sodium, magnesium, calcium, aluminium will use the concept of what? Electrochemistry in electroplating and purification of metals, and batteries and cells used in various instruments. These are the application of electrochemistry. What's the importance or application of electrochemistry? Production of metals like sodium, magnesium, calcium, aluminium in electroplating, purification of metals, batteries and cells used in various instruments. This all comes under electrochemistry. We have several applications of electrochemistry. Okay. To understand the complete concept of electrochemistry, you require some basic terms to understand. So, what's the first basic term? You know that oxidation, reduction as well as redox reaction. Please observe, my dear student, on this slide I displayed three reactions, important reaction: oxidation, reduction as well as redox reaction. Observe here, zinc in elemental form is become Zn2 plus by losing 2 electron. Therefore, if I want to convert Zn into Zn2 plus, zinc into zinc in oxidation state plus 2, you have to remove 2 electron. Therefore, removal of electron, loss of electron or removal of electron is called as oxidation. Reverse ಹೇಳಿ, addition of electron or gain of electron is called as what? Reduction. So, what is oxidation? Oxidation is a chemical reaction where there is a loss of electron takes place or removal of electron takes place. Loss of electron or removal of electron. Here, addition of electron or gain of electron. Gain of electron. Cu in plus 2 oxidation state takes 2 electron and it will become copper. Therefore, oxidation means removal of electron, reduction means addition of electron. If both oxidation and reduction takes place simultaneously, if it takes place simultaneously, such reactions are called as redox reaction. Such reactions are all called as what? Redox reaction. If oxidation and reduction takes place simultaneously, such reactions are called as what? Redox reaction. Once again, my dear students, I'll repeat, three types of chemical reaction: oxidation, reduction as well as redox reaction. Oxidation means loss of electron, reduction means gain of electron. Redox reaction means if oxidation and reduction takes place simultaneously, that is called as what? Redox reaction. Now, second term we have to deal with conductors. What are conductors? The substances which allows electric current to pass through that such substances are called as conductors. Substances that allow electric current to pass through them are known as conductor. In conductor, there are two types: metallic conductors as electrolytic conductors. Metallic conductors are also called as electronic conductors. Also called as what? Electronic conductors. In conductor, we have two types of conductor: electronic conductors and electrolytic conductors. Electronic conductors as well as what? Electrolytic conductor. Electronic conductors are also called as metallic conductors. What are conductors? Conductors are the substances which allow electric current to pass through that. Such substances are called as conductors. In conductors, we have two types of conductor: electronic conductors as well as electrolytic conductors. What are electronic conductors or electrolytic conductors? Electronic conductors or they are called as metallic conductors. Okay, conductors which conduct electricity, by the migration of free electrons. So conductivity is due to the migration of electron. Sometimes conductivity is due to migration of free ions. If the conductivity is due to electron, it is called as electronic conductors. If the conductivity is due to ions, it is called as electrolytic conductors. Therefore, in conductors, we have two types of conductors: electronic conductors as well as electrolytic conductors. Electronic conductors, this conductivity due to migration of free electron. Electrolytic conductors is due to the migration of free ions. Okay, so under conductors, the metals such as copper, silver, aluminum as well as non-metals like graphite as well as various alloy belong to this class. The electrical conductance in this material due to the presence presence of free valence electron, free electrons. This is due to because of what? Free electron. Therefore, conductors which conduct electricity by the migration of electrons are called electronic conductors. Electronic conductors' conductivity depends on several factors. First one, they depend on nature and structure of the conductors, the number of valence electrons per atom, temperature and applied potential difference. What are the four factors on which metallic conductance depends on? The metallic conduct depends on four factors. The first one, nature and structure of the conductors. Nature and structure of the conductor. Second one, number of valence electron. Third one, temperature. Here, in case of electronic conductor, the electronic conductors, the temperature and conductivity or conductance is inversely proportional. Inversely proportional. Please observe here, conductance decreases with increase in temperature. Conductance decreases with increase in temperature in case of electronic conductors or metallic conductors, and that depends upon applied potential difference. Next, deal with electrolytic conductors or ionic conductor. The conductors which conduct electricity due to the migration of ions. Conductors conduct electricity due to the migration of ions are called electrolytic or ionic conductor. Substances which conduct electricity either in electrolytic conductors because of the migration of free ions. Some of the substances, they conduct electricity either in aqueous state or in their molten state or fused state. Aqueous state, molten state or fused state. Such a type are called as electrolyte. They are called as electrolytes or they are called as ionic conductor. The substances which conduct electricity either in solution state or in their fused state are known as electrolyte. The factors which affecting the ionic conductance are once again the nature and concentration of the electrolytic conductor, size of the ions and their solvation, nature of the solvent and its viscosity, temperature. Here temperature and conductance are directly proportional. In case of electronic conductors, it is inversely proportional to temperature. But in case of electrolytic conductor, it is directly proportional to temperature. So, see, observe the difference between metallic conductor. Metallic conductor is also called as electronic conductors. The flow of electricity through the metallic conductor is due to the flow of electron. The flow of electricity through the electrolytic conductor is due to the flow of ions. The flow of electricity does not cause the chemical decomposition of electrolytic conductor. The flow of electricity causes the chemical decomposition of the electrolytic conductor. Electronic conductance decreases with increase in temperature. The conductance is inversely proportional to temperature. Here the conductance is directly proportional to temperature. Resistance of electronic conductor increases with increase in temperature. Resistance of electrolytic conductor decreases with increase in temperature. These are the differences between electronic conductors as well as electrolytic conductors. Okay. Now, third point, I am going to take electrolytes. What are electrolytes? Electrolytes are the substances which conduct electricity either in aqueous state or in their molten state. Aqueous state or molten state alli enaru electric current conduct adre aa substances na navu enanta karitivi electrolytes. Alige student, what are electrolytes? Electrolytes are the substances which conduct electricity either in aqueous state or in the molten state. So, electrolytes are broadly classified into two types. They are strong electrolytes as well as weak electrolyte. What are the two types of electrolyte? Strong electrolytes as well as what? Weak electrolyte. What's the main property of electrolyte? All electrolyte undergo ionization. What is ionization? They split up into cation and anion. If I consider AB as an electrolyte, if they split up into cation and anion, this phenomenon or this process is called as ionization or dissociation. Ionization or what? Dissociation. Okay. So, all electrolytes undergo ionization or dissociation. But strong electrolytes are those which undergo complete ionization. If I am taken 1 gram or 1 mole of an electrolyte, if completely 1 mole undergo ionization, such electrolytes are called as strong electrolyte. If they undergo partial ionization, they are called as weak electrolyte. Therefore, my dear student, electrolytes are classified into two types. Strong electrolytes and matyavadu weak electrolyte. Strong electrolytes are those which undergo complete ionization. Weak electrolytes are those which undergo partial ionization. So, electrolytes that completely dissociate, ionize into ions are called as strong electrolyte. Example, HCl, NaOH, K2SO4, H2, SO4, HNO3. This all comes under strong electrolyte. The weak electrolytes are those we dissociate partially. Aqueous solution, moderate concentration are called weak electrolyte. Example, acetic acid, carbonic acid, ammonium hydroxide. Okay. Non-electrolyte which do not ionize both in aqueous solution and fused state, they does not conduct electricity are called as non-electrolyte. Sugar, benzene, ethanol, chloroform, ether. Those who do not conduct electricity either in their aqueous state or in their fused state, they are called as non-electrolyte. Example, sugar, ethanol, chloroform, urea, benzene, all are example for non-electrolyte. Keep it in your mind, strong electrolytes are those which undergo complete ionization, weak electrolytes are those which undergo partial ionization, Now, we have to deal with next electrochemical cells. What are electrochemical cells? Okay, the electrochemical cells means the devices which are carrying out indirect redox reaction are called as electrochemical cell. They are also called as galvanic cell or voltaic cell. So, electrochemical cell in which chemical energy is converted into electrical energy. Chemical energy if it is converted into electrical energy, if chemical energy, you know that energy neither be created nor be destroyed, but it can be converted from one form into another form. Here I am converting chemical energy into electrical energy by using a device. The device is called as galvanic cell or voltaic cell. Alige electrochemical cell in which chemical energy is converted into electrical energy, so they are called as galvanic cell or voltaic cell. To construct galvanic cell or voltaic cell, you require two electrodes. We require how many electrodes? Two electrodes. So, in which one is called as cathode, another one is called as anode. Cathode and anode. Cathode is also called as positive electrode. Anode is called as negative electrode. Therefore, galvanic cell consists of two electrodes. One is cathode. Another one is anode. Cathode is also called as positive electrode, it is also called as negative electrode, or it is also called as right hand electrode. Anode is called as left hand electrode. So, to construct galvanic cell or voltaic cell, you require two electrodes. One is called as cathode, another one is called as anode. What's the other names of cathode? Cathode is a positive electrode or right hand electrode. Anode is a negative electrode or left hand electrode. What is cathode? Cathode is an electrode where reduction takes place. Anode is an electrode where oxidation takes place. Cathode is an electrode where reduction takes place. Anode is an electrode where oxidation takes place. These two electrodes of the cell are called, and these electrodes are also called as half cell, redox couple or single electrode. The summation of these two half cell reaction gives the cell reaction. Therefore, overall redox reaction that takes place in the cell. Therefore, any galvanic cell or voltaic cell, my dear student, consists of how many electrodes? Two electrodes. One is cathode, another one is anode. Cathode is called as positive electrode as well as right hand electrode. Anode is called as negative electrode as well as it is also called as left hand electrode. What exactly cathode? Cathode is an electrode where reduction takes place. Anode is an electrode where oxidation takes place. Now, what is the free energy? Free energy is a driving force. Free energy of the spontaneous chemical reaction of this redox reaction of a cell drives electrons move from negative electrode to positive electrode. That is, electrons flows from anode to cathode. So, with the free energy, that is free energy, the driving force is called as electromotive force, EMF of the cell, electromotive force. The free energy of the spontaneous redox reaction of the cell drives the electrons move from anode to cathode ಅಥವಾ negative electrode to positive generating EMF. What is EMF? Electromotive force of the cell is defined as it is the electrical potential difference. It is the electrical potential difference between the two electrodes when no current is drawn from the cell. The electrical, what is EMF of the cell? EMF of the cell is defined as electrical cell potential, electrical potential difference, electrical potential difference between the two electrodes, electrical potential difference between the two electrodes when no current is drawn from the cell. It is measured by using potentiometer. It is measured by using potentiometer. How can you measure the EMF of the cell? EMF of the cell is measured by using potentiometer. One more term I have to explain, cell potential. Cell potential is the same electrical potential difference between the two electrodes when the cell is being discharged. When the cell is being discharged. When the cell is being discharged. So the electrical potential difference takes place between two electrodes is called as cell potential. It is measured using voltmeter, which is measured using voltmeter. EMF of the cell is measured by using potentiometer. Cell potential is measured by using voltmeter. The EMF of the cell is calculated by using formula E cathode minus E anode. How do you calculate EMF of the cell? EMF of the cell is calculated by using formula E cathode minus E anode. What is E cathode? E cathode is the electrode potential of the cathode. E anode is the electrode potential of the anode. So how do you calculate EMF of the cell? EMF of the cell is calculated by using relationship E cathode minus E anode. What is E cathode? E cathode is the electrode potential of cathode. E anode is the electrode potential of anode. Then question arises, what is electrode potential? I already given definition for EMF of the cell as well as cell potential. But to calculate EMF of the cell, you require electrode potential of cathode and electrode potential of anode. EMF of the cell is equal to E cathode minus E anode. E cathode minus E anode. So this is how do you calculate electrode potential value. My dear student, in next class, while I'll coming to explain about the electrochemical cells, once again in depth I am going to discuss about electrochemical cell by taking Daniel cell as an example. There I am going to give definition for what is electrode potential. How do you calculate electrode potential? Because electrode potential is very, very important to calculate EMF of the cell, because EMF of the cell is given by formula E cathode minus E anode. What is E cathode? E cathode is electrode potential of cathode. E anode is electrode potential of what? Anode. Therefore, next session in depth I'll discuss about electrochemical cell by taking Daniel cell as an example. Therefore, my dear student, today I discussed about all basic terms which are required to explain the concepts which comes in electrochemistry. Next session, I'll completely discuss about the electrochemical cell by taking which one as an example? Daniel cell. Until that, goodbye. Thank you.